recording to start. Okay. Yeah, there's quite a few committee members here, but to everyone not, thanks for coming along. If you don't know anything about Engineers Without Borders, I'm sure we'll be happy to answer questions about it at the end, but we're a student society that tries to promote globally responsible engineering. And so it's a bit more about engineering for good. Kit, take that away and yourself.
Okay, thanks, Nathan. Welcome, everybody. My name is Kit. I will be talking to you and sharing with you about what I do. Specifically, I'll introduce myself and what I do, and then I'll share with you what is the situation around the work that I do in terms of the engineering principles and skills, what are the leadership and what are the managerial challenges that I see. And then I'll lay out the root causes of these issues around energy and climate change, and what are the tools and techniques that are available to help us and also you as future engineers and future leaders to make energy and climate change issues less impactful in terms of the damage, and also take the issues forward into the future. Just a very quick introduction of myself. That is how I look like. I am a chemical process engineer. I graduated from Sheffield about over 20 years ago. So my role primarily on a day-to-day basis is around two major themes. One is consultancy work to help organizations improve their so-called ESG, which stands for environment, health and safety, and also corporate governance. So this is where I help organizations identify opportunities for improvement, help them quantify the opportunities, help them create business cases for improvement, and help shape and simplify the often complex technical issues, and also the complex nature of engineering solutions in the energy and climate change fields. My other primary source of work is around training, specifically providing training to organizations to do the same thing, or to help them increase capability to improve their, again, ESG. Now, sometimes I do pick up some governmental work associated, again, with ESG. I've worked with the British government, the Singapore, the Middle East government, India, and also a few countries in Africa. Now, apart from my two main portfolios of work, I also volunteer as a standards writer. So I am on 3 separate committees, one on energy management, one on water management, and also circular economy. And I chair the development of 2 ISO standards on energy auditing and also on water assessment. So let's look at the current state of play within the energy and resource efficiency. Now, if you ask top managers, the C-suite, they very readily tell you why they need to pay attention and take action on improving their energy and resource efficiency. This survey is done by The Economist back in 2013, and they actually show why top management say energy and resource efficiency is important. Now, what I've done is to highlight 5 of the reasons top managers say it is important. Right at the top is about ensuring security of supply of energy to their company. Number 2 is the cost benefit, complying with the regulation, improving the organization's image and pressures from customers, shareholders, and also from their employees. Now, these 5 were highlighted because it makes up more than 80% of the reason why top managers say energy and resource efficiency is important. Now, what we are seeing is there is an increase in pressures from customers, from the shareholders, their finances, and also the employees, driving energy and resource efficiency forward in the corporate world. So let's see if this translates into real action in the real organization. If we assume that the burgundy square or the red square, depending on your screen resolution and color scheme, so if you assume that red square as the total energy consumption of the planet, every countries are included. Now, based on the available knowledge we have today, and also all of the technologies that are commercially available. Now, this means we discount all those that are still in the R&D phase. We can reduce energy consumption by 73%. And if this is true, we only need to decarbonize 27% of the remaining energy consumption and its impact on the planet. And this would be through the use of renewable energy sources and also to apply carbon capture technology. Now, based on knowledge and practice, we also know approximately 25 to 35% of the consumption can be saved with no cost or very little cost implication, or little changes in operating requirement. And yet, on a global basis, we are only achieving 1.2% reduction every year. In fact, this has been consistent over the last 10 years or so. And against this background, the global energy consumption is increasing by 2.6% year-on-year basis. So we are not really seeing a reduction in consumption and hence the impact on climate change. We are seeing an increase in that consumption and impact. Now, just for reference purposes, I'm sure all of you know about the COP, the Paris COP arrangement. Now, if we want to keep the impact of climate change to 2 degrees, we need to be reducing energy consumption at a rate of 3% every year up to 2050. If we want to keep the increase in average temperature to 1.5 degrees, we need to be achieving 7% reduction. Now, the issue isn't really about energy consumption, but the impact of this consumption on the planet. Now, for that, we need to look at the global carbon balance. Now, very briefly, this is a visual depiction of all of the available carbon sources on this planet. We are consciously discounting the bit of the carbon that we cannot access, because if we can't access it, it doesn't exist for consumption purposes. Now, our present day energy consumption, we are sending approximately 33 gigatons of CO2 to the environment. Now, we also know land-based vegetation and plant, when they die over hundreds and thousands of years, get converted back to fossil fuel. Now, on average, that is about half a gigaton a year. Now, we also know that plants do absorb CO2 through photosynthesis processes, and that occurs at a rate roughly about 1.5 gigatons a year. Now, that figure is a reducing figure because of deforestation. We are rapidly reducing the amount of forest on this planet for commercial purposes, for industrial purposes, and also for growing food. Now, we also know, based on scientific research papers, that approximately 2 gigatons of CO2 is absorbed by our water. Now, in particular, our fresh water, because fresh water is a very valuable resource for us as human beings, for the land-based plants, and also animals. Fresh water only represents about 3% of the total water available on the planet, and a significant bunch of it is actually locked up in the two polar ice caps. Now, again, we need fresh water for our survival. Animals need it for survival, and the plants and vegetation also need it for survival. What we cannot use is acid. Now, water, as you know, when combined with CO2, actually form acid, and that is actually detrimental to life, either humans, animals, or planet. And the available fresh water is a decreasing amount. Now, we also know dead aquatic animals and also aquatic plants, similar to land-based vegetation and animal, do convert back to fossil fuel over many hundreds of thousands of years, and that occur at a rate of about 0.5 tons a year. Again, this is a reducing number. Because the amount of plants and animals, fishes available in the sea is also reducing. Based on the latest documentary, we found out that between 1940 and 2020, there is a 97% reduction of big fish populations in the ocean, and it's increasingly more and more difficult for fishermen to catch large hauls of fish in our seas and ocean. We see it all the time in the news, media, and also in documentaries. In fact, if you look into this paper by Johan Rockström, Johan did a large group survey supported by a team of 30 international experts spread around the world. Their work centered on identifying what is the safe boundaries of consumption within this planet. Now, if we operate within this so-called planetary boundaries, the planet will be able to regenerate itself and adjust to provide a safe living space for everyone on the planet. If we consume far more than the defined planetary boundaries, then we tip the ecosystem on one side, where it becomes more and more difficult for the planet to regenerate and recover from that change. And as you can see, we have actually exceeded the planetary boundary for several of the key consumption, and climate change being one of them. Depending on where you are, the rate at which we are consuming energy is equivalent to about 2.5 to 4 times the rate at which the planet can regenerate the sources itself. Now, the root cause, coming back to what we said, why are companies not doing energy and climate change activity versus the promise, and also versus what they say is important, is down to a few factors. It starts off often with uncommitted leadership. And when I say uncommitted leadership, I'm talking about companies that prioritize profits over other issues. For example, the planet, the availability and affordability and the environmental implication. Inevitably, they will start with a poor design rather than having a design of a building or a plant that is energy efficient, that is low carbon. They will go instead with low cost. Now, low cost to a large extent would actually mean low capital costs, but big energy consumption costs throughout its design life. Now, these poorly designed plants or building will be poorly installed and poorly commissioned. It will be poorly operated, poorly maintained, and therefore giving a poor energy and resource efficiency performance. And that results in frustration. Now, the interesting thing about human being, even in an organizational level, is that we never learn. And the cycle continues to repeat itself even in the same company. At the end of the day, energy cost and environmental cost is really just a small cost for most companies. The issues and the failure with what we have done so far is that a lot of organizations and a lot of countries have addressed and recognized the energy and climate change issue as a single issue which involves a single party. Now, from this visual representation of how poor energy and climate change performance result, it is in fact a multiplayer, multi-issue problem, and it needs to be addressed using many different ways. And hopefully what you will notice is that there is some form of technical analyses. This is where you guys and myself come in as engineers. We are very well versed with a lot of the technical requirements and analyses and the determination. Now, that technical analysis need to be aligned with the strategic direction of organization. If they are not aligned, all the technical analyses will not result in organizations moving the energy agenda and the climate agenda forward. Now, in addition to this, we also need active management to pull the various elements and the various parts of the organization together. In fact, what we are really interested in is that yellow tiny little triangle where all 3 parts overlap. Now, this is where you will find organizations will actively address its energy consumption, minimize its environmental and climate change impact. If you take one element or 2 elements out of the equation, we know nothing happens in the organization. And this is where we as engineers, future managers, and future leaders come in handy, because the way we influence organization depend on the specialist studies that we have, the specialist skills, and also the different roles that we take on in the future. And we need to really bump organization towards the middle where everything can actually move on and we enjoy reduced energy consumption and avert the climate change impact. Now, the solution to our root cause are very simple and straightforward. It starts with good and committed leadership, putting in place low energy consumption designs. We install it right, we commission it right, we operate the plant right, we maintain the plant right, and that is the answer to our present problem. The application of these tools depends on multiple things. The first one is recognizing that there is a need for better knowledge. How do all the technical elements interact? How do we analyze them and how do we quantify them? Those are important. In industry, you will find there are a lot of people who is not comfortable in engaging with the level of technical details. So we need to find a way to communicate the analyses and what it means to a simpler audience. When I say simpler audience, I don't mean they're stupid. I just means how do we simplify the way we communicate things such that the general public can understand them. Secondly, is about how do we use analyses to help us, the companies, understand their energy consumption? How does it compare to the other organizations? How does it compare with the opportunities available for improvement? Now, rather interestingly, I have worked with one company in the past where they publicly publish their energy performance. And when I looked at that data, it would appear that their 30-year-old plant is performing better than a new plant that is built today. That can't be right. In fact, as engineers, we can use the various thermodynamic tools to help us analyze what is the theoretical limit for the energy consumption in various plants. And when we do that, in fact, that company was declaring that they were performing significantly better than what is theoretically possible. And that is just nonsense. Now, then the third type of tools is how the tools that actually help us design better buildings and better plant. What are the various tools and techniques to help us design low energy buildings, for example? How do we apply the various tools and techniques to minimize energy consumption at design? The next one is about designing better buildings. How do we improve on our buildings and our processes? We also need to provide an option to supply energy sources that are inherently efficient and also inherently low in carbon and high in utilization. Of course, better maintenance and also alignment with the strategic direction of each individual organization. So these are the tools that we have as engineers and also from our experience and learning in leadership and in management, and these will come in handy. Now, the way we apply these tools changes depending on the life cycle of the organization. And when I talk about life cycle, I am talking about life cycle of the company, and it will start from a business idea to concept design, detailed design, construction, testing, commissioning, operation and maintenance, and final decommissioning and disposal. For most of my colleagues, including myself, and I would hesitate to guess most of you guys in the future, you will be working with organizations that are in the operations and maintenance phase of their life cycle. Now, why would I say that? It is because there are more buildings that are currently occupied and available compared to the buildings that are in design mode yet to be constructed. Similarly, there are more process plants and manufacturing plants present compared to those that are being designed and being developed. And the influence and how much we can help the company reduce consumption, reduce environmental impact, really depends on where they are on this stage. Now, to give you an example, I have worked with quite a few dairy plants in my work. Now, one of the most interesting feature about a dairy plant is that all of them will have a steam plant operating at 10 bar gauge. They will distribute steam at 10 bar and then let it down. Now, if you were to look at a dairy plant very, very closely, they don't need steam at 10 bar. In fact, they don't need steam at all. All they need is hot water at 80 degrees max. So in this situation, if we were to be able to design a hot water plant to generate 80 degrees hot water, it will be significantly cheaper to design, significantly cheaper to install, and will also have less health and safety requirements compared to a 10 bar steam boiler system. And that is where, if you can actually influence the design right up at the business idea stage or the concept design stage, you can affect the consumption and the environmental impact over a longer period of the organization. The second life cycle that will determine the combination of tools and techniques you use is what is called the product and the service life cycle. And most of the time, it will start with some form of raw material, some form of pre-processing, manufacturing, distribution, use, and disposal. Again, similar to the organizational life cycle, where you come in also can influence the organization's energy consumption, environmental impact, and help avert climate change. So I hope I've given you a broad picture of the different types of engagement that you can be involved in the future. For me, I do enjoy doing a lot of my work, and I do enjoy pulling together the leadership pieces, the technical analyses and engagement pieces, and the managerial piece. And I do find that these three are very, very crucial in helping organizations make a real and meaningful impact. And I hope it has given you some ideas on how you, as future engineers and leaders in the corporate world, can help to reduce consumption, reduce environmental impact, and help us move the climate agenda forward. So with that, thank you very much, and I will hand the session back to you guys, and I'll be happy to answer any questions you may have.
Thanks, Kit. That was I found that really interesting. So yeah, as Kit says, anyone is welcome to ask questions now. You can put your video or mic on and ask, or if you aren't comfortable with that, just put it in the chat. The session is being recorded. I've learned that unless I start it off, there tends to be an awkward silence as people think for questions now. But like you were talking about leadership, how can we sort of incentivize and create? Is he gone? He's disappeared. Hopefully it's an internet thing. Give it a minute. If anyone has any questions about EWB Sheffield, then fire away. Is everyone from Sheffield or?
Rip. Hopefully you can come back.
Surely his internet's gone. Oh, here we go.
Okay.
About that, I don't know why I got disconnected.
Very strange. Maybe there's internet problems. Yeah, as I was saying, you were talking about incentive, like creating committed leadership. Like, how do we do that? Do we just show that it's like economically beneficial for them to increase like resource efficiency, or does it have to come in the form of like better ISOs or legislation? What do you think? How do you think we can incentivize that?
Yeah, so I think for me, I would say forget about ISO standards. I would say use your human skills, trying to decipher when you are communicating with the leaders of the company. Trying to find out what is their primary driver for improvement. They could tell you that it is part of the strategy, it's part of their vision or mission statement, or they could tell you people is important. So a very good example is coffee. You guys know Costas Coffee? So Costa Coffee is a very interesting organization in which they have three very, very important drivers. One is about doing good for the planet. The other is about doing good for the employees. And then it's about doing good for the company. And they evaluate all three benefits for each of the projects. So when you're working with Costas, you need to find out through your interaction, what are the reasons for them to take action? In Costas, that would be that three criteria. So in your communication and in your business case development, that is the three things you need to hit. Some companies, especially certain American companies, are very common, where everything is about cost. Then it is about how do you collect and quantify all of the financial benefits, because a lot of the projects that we see not only provide energy benefits, it also reduce water consumption, it reduce wastage, it may help reduce maintenance. It's about adding up all these little components to make the project look interesting. So I think those are the key tools. It will need to be supplemented by some of your leadership knowledge, some of your management skills that you will develop over time to communicate and smoke out what are their motivators.
That's really interesting. And I know you've worked all over. So are there like big differences in the attitudes towards sort of environmental factors and efficiency in different countries?
They are. Funny enough, there are also differences in technical capabilities. So let's talk about technical capabilities first. So British, American, and Australian organizations tend to like to use and the big stuff. How people are actually less technically capable. They tend to be less capable to talk about the technical specific elements of the projects. For example, economizers. You tell them install an economizer, yep, they understand what an economizer is, but you go a little bit more detailed, you lose them completely. If you go to countries like India and China, and in the Southeast Asian region, you find them to be very, very technically capable, and you can actually discuss the technical elements to death, and they will still be very interested, but they are very poor in the leadership skills and the management skills, and to bring those together and make the project happen. So those countries have a complete opposite problem to us in the Western culture. So those are the two extremes I tend to see. And when I look at a lot of the countries in Africa and in the Middle East, for some reason, they tend to think that throwing money at a problem will solve itself. And we can see from factual results that throwing money at companies. So South Africa is a good example. They actually encourage people to save energy, and the governments will actually pay you to buy your energy savings equivalent. Effectively, what they're doing is government is asking you to save energy, and they will pay you for the equivalent of energy saved. Again, if you look at actual result, it is not happening because the leaders of the companies are not engaged. The managers are, because it helped boost their financial bottom line, and it's not going to happen. So if you remember the three parties that we talk about, the technical analyses, the leadership, and the managerial requirements, we need all three together. And from a geographic perspective, I don't see any one country dominating in all three. However, there are specific examples of company who do very well in all three of them. Yeah, and that is what I tend to do in my spare time, collect these type of examples and tell them when I go around.
That's really interesting. Thanks for that. Does anyone else have any questions? And feel free to put them in the chat if you want to talk. Also happy to take questions about EWB if this is anyone's first involvement with us.
Yeah, one thing that I wanted to ask is, because a lot of these, it's not even like doing this will help to protect the planet, it's doing this helps the company in almost every respect, in terms of it saves them money, and as well as being morally the right thing to do.
Mm-hmm.
So why do you think there's been such little take up, essentially, of these ideas like this?
Let's break that down into segment. Let's talk about awareness first. Are companies and are people aware of the environmental impact? And the answer is yes, because there is an emergence of documentaries, a lot of researchers looking into these type of analyses and scenario. We also have, for example, the emergence of activist groups like the climate emergencies, etc., etc. So people are aware of the issue, and personally, a lot of them would actually want to do something. The issue then becomes, how do we implement it? Because in the future, when you go to work, you are actually sucked into a corporate machine. And that corporate machine is about helping the company generate profit, which then funds the whole cycle. And that profit, then that machine is kind of like a giant ship or a giant spaceship. It takes a long time to make changes and course correction. And to do that course correction, you need someone shouting out, I need to make course correction. Typically, that would be the captains and the leadership team of the organization. And then it needs the managers in the various departments to actually do that course correction and steer the boat or the spaceship in a different direction. And then you've got the engineers doing the calculation, doing the projection, and do how much course correction is required. And collectively, most of the organization, that is where problem starts. Which is why I presented that 3 overlapping circle and the need to get to that triangle. And that will require multiple different players in the organization pulling the ship together. Now, in the past, in fact, I'm one of the culprits, and a lot of my colleagues, for example, in the other government department, used to think that this is an energy issue, so we just put in an energy engineer, and that person will solve the problem. And when we look at why energy reduction and climate change issues are not going away, we continue to look at a single player, single solution issue. Whereas now, over very recent, actually, it started in 2011, where we actually changed the problem statement, and then we saw that there's actually a multiple different players and each pulling different levers in an organization. And that is where we need to go. And this is also where you guys will be coming in and move the ship forward in the future.
Also had a question from Harry in the chat. It says he says, thanks, Kit, very interesting. He would like to ask, what skills and software do you use on a day-to-day basis, and are there any books that you would recommend? He's in the library, which is dedication at this time of night. So don't mark.
Wow, interesting. Books. There are a lot of books, technical analyses book that is available. There are also a lot of management system books that are available. And there are also a lot of change leadership books that are available, but there isn't one that have all that overlap all the 3 of them. So interesting. If you are interested in a topic, I would ask you to Google Without Hot Air. Is a book by David Mackay, a former professor from Cambridge. He's actually made a very accessible book available free of charge in the internet. You can actually find some basic analyses and basics on how the different things stack up. That is a good start. And if you want additional references, let me know. I can actually search some and send it to you guys.
Yeah, I guess if anyone emails us, we're happy to forward it to Kit. I'll put our email in the chat. Also had a question from Nicholas. It says, from what you said, it seems a lot of the main responsibility seems to fall on leaders and managers. How might an employee or graduate engineer at the bottom of the company ladder take steps to cause effective change at the company?
Good question. And my answer to that question is to look at IBM, the computer company. IBM as a company started to actively manage and reduce its environmental impact and energy consumption since 1974, even before I was born. And they have consistently every year reduced its energy consumption year on year, every year, 2% without fail. And what was interesting is when I looked at how IBM started that conversation and the need for improvement. It did not start from the top management or the management. It started right at the shop floor, at the engineers level, at the sales people's level. Because what IBM did was they started to collect and coalesce together a large group of employees, junior level, who are interested to work in a company that are environmentally forward thinking, that are responsible in its own consumption and environmental impact. I mean, if you remember back in 1974, at that time, no one was even talking about climate change. And that was the real interesting thing. It started off right at the bottom of the organization, that group of employees who are committed to create an environmentally responsible company, grow and grow and grow, and eventually it got the attention of middle management and top management. And that was really how IBM got started on this journey. It does not need to start with the leadership putting a directive down the organization. The reverse is also true. Yeah, and I've actually seen even a Swedish furniture company who also had the same model of bottoms-up engagement. Yeah, so don't feel that you are a graduate engineer and you can't influence corporate decision. If there is sufficiently large group of you guys who are equally passionate about energy, environmental, and climate change, and group together, it can happen. Similarly, we also see more people or investors and owners who have actually stopped the board meeting because there isn't sufficient progress in reducing consumption and improving the environmental performance. So we are seeing two different groups of people also pushing the corporate agenda forward. So hope is at hand. And it relies on you guys to actually push that agenda.
I'd say that's a great reason to get involved with EWB and meet like-minded engineers who are passionate about improving the environment through engineering. Just plug the society a bit there. Are there any other questions? Right. If not, then say thanks to Kit for a really interesting talk. Oh, there's another question in the chat.
Do you think the interconnections, not sure what you mean by interconnections. Are you referring to the interconnections between Scotland and England, England and Ireland, and England and Amsterdam and France? Okay. Okay, so thank you for that clarification. Yes, it is important and useful from the perspective of guaranteeing the security of energy supply. From that perspective, it is useful. However, our existing power network is still deficient in terms of how it interfaces with, say, wind turbines, let's say, the solar farms and the PV cells that people have on their roof. Because the funny thing about solar is good in the day, and in the day, no one's consuming power. And wind, you can hardly predict when the wind is blowing. And to a large extent, the existing network needs to be coupled by some form of energy storage. And improving the interconnectivity just buys time for the network to actually get itself ready for the future.
Great. And Nicholas has asked, it says it's our first experience, his first experience with EWB Sheffield. How can I get involved more? That is a brilliant question. So we run a number of one-off events. We do one of these engineering for good talks every month, and we've got a Green Careers Fair coming up next month as well, and we're running a social next week. So all the information about those events is on our Facebook page, which I've just put a link to in the chat. We also run a number of projects, so there's more information about those on our website. And we can give you, if you've got questions about how you want to get involved with those, I would email us. I'll put our email in the chat a bit further up. Yeah, and the projects run, they run every week. We're trying to run them as best as we can given the current situation, but luckily we still have access to the iForge. But yeah, for the one-off events, I'd check out the Facebook page. And Harry has asked a question for you, Kit. What role do you think hydrogen will play in the energy future of the UK?
Interesting you say that. Nathan, you should know this. Leeds is powered by hydrogen heating. In fact, that's the only city in the country at the moment whose heating and is actually run based on hydrogen. Hydrogen is kind of similar to decarbonization techniques in the sense that it takes out the carbon right at source before they actually pipe it to the individual users. It is slightly different to demand reduction. Demand reduction is about each person taking the responsibility to reduce the energy consumption. Hydrogen as a fuel is a matter of source, where the energy is coming from. And for me, I think there is a need to address the issue from the supply side and also from the demand side. And as you can see in my previous presentation, if we can reduce demand, technology says we can do so by slashing up to 73% of the demand based on today's technology. And then we can think about decarbonization. Now, the less we reduce demand, the more we need to decarbonize. And I think both supply and demand needs to be addressed at the same time.
That's really interesting. So I'm aware that we're getting towards 7 now, so I'll put out a final call for questions. But Faye's put in one saying, will it ever be possible for a large country to go 100% renewable?
UK already does on select days. So if we look at the power networks, for example, during cool summer months, we already see the country being powered purely from renewable energy, although it is not going to happen during winter. And in cool summer days, that's when we have good sunlight and a maximum condition for the solar cells to operate at peak efficiency. And we also got a good constant breeze from the ocean that generates a lot of the electricity requirement. However, these do not coincide during winter. So we already do on select days, but there are more that can be done. Yes, I do agree that.
So, Nicholas, in response to your question about accessing the recording, I will. I'm going to look at getting it put on our website, the WordPress one that I sent a link to earlier, www.ewbsheffield.org. But this is the first time we've recorded one of our events, so it may take a while. If you email us, I can send it. I can share it with you directly as well. Oh, great to have you from Newcastle, Harry. I guess that's one of the benefits of these online events. We get people from all over the north of England and the south and Canada. So, great. Unless there's anything else, I want to thank Kit for his time, and thank everyone for coming.
Thank you very much.
I jumped the gun again. If I was asked why hasn't the UK tapped into energy harvest from waves or the ocean?
Can I play a sly comment and say politics? No, there are actually several factors at play. It's a little bit complicated to describe the energy supply and demand scene in a short period. But long story short, there are some politics involved. There are also a lot of complex pieces when we look at supply and demand. Again, we are looking at multiple stakeholders, each having different interests, and optimizing that together to get at an optimized solution is very, very complex. Again, if you're interested in those things, I will and Google the politics of energy or energy politics or energy economics. It opens up a completely different field, but it's a very, very specialized field of discussion.
Great. It's really interesting. So, I think that's probably it for questions. Everyone enjoy the rest of your evenings, and thanks to Kit for your time again.
No problem, Nathan. Thanks very much. Thanks for inviting me. Bye.
Thank you very much.
Thank you.
Bye.